This is the first lab of computer engineering / computer science 138, and it's just an introduction on the tools that we're going to be using, and this is Wireshark. So we have instructions and the requirements and everything here. So this is our getting started. One's understanding of network protocols can often be greatly deepened by seeing protocols in action and by playing around with the protocols. Observing the sequence of messages exchanged between two protocols' identities, delving down into the details of protocol operation, and causing protocols to perform certain actions, and then observing these actions and their consequences. This can be done in simulated scenarios or in a, quote, real, end quote, network environment such as the internet. In the Wireshark labs we'll be doing in this course, we'll be running various network applications in different scenarios using our computer. We'll observe the network protocols in our computer in action, interacting and exchanging messages with protocol identities, executing elsewhere in the internet. Thus, us and the computer will be an integral part of our live labs. We'll observe and learn by doing so. So in the first Wireshark lab, we'll be getting acquainted with Wireshark, the program, and we'll make some simple packet captures and observations. The basic tool for observing the messages exchanged between executing protocol entities is called a packet sniffer. So again, the packet sniffer is the basic tool for observing messages exchanged between executing protocol identities. So when we have messages exchanged between protocol identities, that's a packet sniffer, and that's the tool for it. As the name suggests, a packet sniffer captures, and this is the sniffing, messages being sent / received from or by the computer. It will also typically store and or display the contents of the various protocol fields in the capture message. A packet sniffer itself is passive. It observes messages being sent and received by applications and protocols running on our computer, but it never sends the packets itself. Similarly, received packets are never explicitly addressed to the packet sniffer. Instead, a packet sniffer receives a copy of packets that are sent / received from / by application and protocols executing on our machines. So we're not receiving the actual packet, we're receiving a copy of it when we receive and when we send things, because we never send the actual packet itself. Now we look to this figure right here. Figure 1 shows the structure of a packet sniffer. At the right of our figure 1 are the protocols. So to the right are our protocols. In this case, we have internet protocols and applications, such as the web browser or FTP client. Those are the applications, and these normally run on our computer. The packet sniffer, shown within the dashed rectangle in figure 1, that's going to be this area right here, is an additional to the usual software in our computer and consists of two parts. So this is what normally runs on our computer, applications and the transport, and this runs with the normal software on our computer. The packet capture library receives a copy of every link layer frame that is sent from or received by our computers. Recall from the discussion, section 1.5 in our text, that messages exchanged by higher layer protocols such as HTTP, FTP, TCP, UDP, DNS, or IP, all are eventually encapsulated in link layer frames, and these link layer frames are transmitted over physical media such as Ethernet. So this information is captured and all of it's copied and transferred this way. In figure 1, the assumed physical media is an Ethernet. That's our media of transport. And so all upper layer protocols are eventually encapsulated within an Ethernet frame. Capturing all link layer frames thus gives us all messages sent or received from by all protocols and applications executing in our computer. So this is the to from network. So we have our application here. It goes through this transport. It goes across the Ethernet, packet capture, and then the packet analyzer, which is all part of the packet sniffer. The second component of a packet sniffer is the packet analyzer. This displays the contents of all fields within a protocol message. In order to do this, the packet analyzer must understand the structure of all messages exchanged by protocols. For example, suppose we are interested in displaying the various fields in messages exchanged by the HTTP protocol in our figure 1. The packet analyzer understands the format of Ethernet frames and so can identify the IP datagram within the Ethernet frame. It also understands the IP datagram format so that it can also extract the TCP segment within the IP datagram. Finally, it understands the TCP segment structure so it can extract the HTTP message contained in the TCP segment. Finally, it understands the HTTP protocol and so on. We're going to be using the Wireshark packet sniffer. This is this link for these labs, and this will be found in the description below the like button. It allows us to display the contents of messages being sent/received from by protocols at different levels of the protocol stack. Technically speaking, the Wireshark is a packet analyzer, and it uses a packet capture library in our computer. Wireshark is a free network protocol analyzer and runs on Windows, Linux, Unix, and Mac. I'm going to be running it on Windows and maybe sometimes on Mac as well. It's an ideal packet analyzer for the labs. It's stable, has a large user base, and well-documented support. That includes a user guide here. We have man pages, which are the manual pages right here, and a detailed FAQ. So that's good to note. So I'm going to open the Wireshark link, and it just looks like this. Getting Wireshark. In order to run Wireshark, we will need to have access to our computer. It supports Wireshark and the libcap or WinPCCap packet capture library. The libcap software will be installed for us if it's not already installed in our OS when we install the Wireshark. So we can see this for a list of supported OS and download sites. So to install Wireshark, we're going to go here and download and install the Wireshark binary for our computer. So we're going to go into here. We want to download Wireshark. I'm just going to do the Windows installer, 64-bit. So we're not changing anything. We didn't click anything. We're just going to have that installed. And while that installs, we'll go back to the lab. When we run the Wireshark program, we'll get the startup screen as shown below. So we're going to wait for this to install, and then we are going to come back to it once this finished loading. Should have been done. Now it finishes, we have our license agreement. We can click I agree, and then we are just going to continue installing. So I'm not going to click any of these. I'll just click install. Should extract it and install the drivers. And let's keep going with the lab. Once it's complete, we can click next and then finish. Now searching it up on my computer, I have the Wireshark here. So now we have also installation complete right here. We'll click next, and we have to reboot the computer in order to fully install it. So what we're going to do is just finish, and we're going to reboot the computer. So now we are going to load into our Wireshark. We open the Windows Start menu after we restart, and then it's going to look like this for the edition that we're using. So it's not going to look like what we have here, but it's going to have something similar when we connect it like with something right here. So we're going to connect it like this, and then we have our time, our source, destination, protocol, length, and info. If we want to change the way we view time, mine is displayed of time of day because I think it's a little bit different, but we're using time of day for this. And so with time of day set, we have all of these that are being updated, and that is from my computer. So up top, we have our command menus, and then we have a display filter. Now with the display filter, we can filter out specific things to find things easier. And then underneath that, we have the listing of captured packages, and that's the part that's changing right now. And then we have the details of a selected package header. So the details are in here, and we will go more into depth with that in a second. Then we have the package content in hexadecimal and ASCII. So that is going to be below here, and we have it also in decimal, I believe right here. And then we have the hexadecimal, and then we also have ASCII to the far right. So this is our figure 3. The Wireshark interface has 5 major components. The command menus. It's a standard pull-down menu located at the top window. Of interest to us now are the file and capture menus. The file menu allows us to save the captured packet data or open a file containing previously captured packet data and then exit the Wireshark application. The capture menu allows us to begin packet capture. The packet listing window displays a one-line summary for each packet captured. So the packet listing window is the part right here with the different colors. So the packet listing window displays a one-line summary for each packet captured, including the packet numbered. It's assigned by Wireshark. This is not a packet number contained in any protocol's header. The time at which the packet was captured, the packet source and destination address, the protocol type, and protocol-specific information contained in the packet. The packet listing can be sorted according to any of these categories by clicking on a column name. So if we go here and we were to click it, whatever we wanted, we can sort it just like this. We can sort it by numbers, ascending or descending, the time, the source, and same thing for all of that. But I'll just change it to the number for now. The protocol type field lists the highest level protocol that sent or received this packet, i.e. the protocol that is the source or ultimate sync for this packet. Then we have the packet header details window. So the packet details is right here. It's going to be this part right here for us. The packet header details window provides details about the packet selected, highlighted in the packet listing window. So if we were to click something in the packet listing window, like up here, we would have the information for it be updated down below in the packet header details. These details include information about the Ethernet frame, assuming that the packet was received over an Ethernet interface, and believe it's the same thing over Wi-Fi, just it's over Wi-Fi, and IP datagram that contains this packet. The amount of Ethernet and IP layer detail displayed can be expanded or minimized by clicking on the plus/minus boxes to the left side of the Ethernet frame or IP diagram lane in the packet details window. If the packet has been carried over TCP or UDP, TCP or UDP details will also be displayed, and this can similarly be expanded or minimized. Finally, details about the highest level protocol that sent or received this packet are also provided. So for us, we have these arrows and we can expand the information that's inside of them. The packet contents window displays the entire contents of the captured frame in both ASCII and hexadecimal format, and that's the lower part right here. Towards the top of the Wireshark graphical user interface is the packet display filter field, and that is the very top part right here, where it says apply a display filter, which a protocol name or other information can be entered in order to filter the information displayed in the packet listing window, and hence the packet header and packet contents window. In the example below, we'll use the packet display filter field to have Wireshark hide packets, except for those corresponding to HTTP messages, which we're going to be looking at. And this is where we're taking Wireshark for a test run, and we're going to be trying out the software. And so we're going to start up our software just like this. I'm going to reset it by stopping it, and then I'm going to be clicking the start capturing packets, continue without saving, and that's going to restart it. And then if we wanted to, we can restart the current capture just like that. And that's going to begin our capture. And it's going to be a little bit different than these instructions because I believe these are slightly out of date. Now from here, while our Wireshark is running, so we can see that it's running here, what we're going to want to do is we're going to get this URL. So I'm just going to middle click it so it opens in a new window. Once it opens, I'm going to click it and it says, congratulations, you've downloaded the first Wireshark lab file. And so once we have that, what we want to do is look at the instructions again. So after our browser has displayed the intro Wireshark file, stop the Wireshark packet share by selecting stop in the Wireshark capture menu. So we're going to come here, we can click stop, go back to the instructions. The main Wireshark window should now look similar to our figure. We have live packet data, and it contains all protocol messages exchanged between our computer and other network entities. The HTTP message exchanges with the gia.cs.umass.edu web server and should appear somewhere in the listing of packets captured. So we have packet, it should be somewhere in here, but we see that we have a lot of packets in here. So even though the only action we took was to download a web page, there was way more protocols running on our computer that are unseen to us as the user. And we'll learn more about these protocols throughout the text, but we should just be aware that there's more going on than meets the eye. Also for the sixth one, just some more information. Once we have the page displayed in our browser, in order to actually display this page, our browser will contact the HTTP server at gia.cs.umass.edu and exchange HTTP messages with the server in order to download this page. And this is discussed in section 2.2 of the text. The Ethernet frames containing these HTTP messages, as well as other frames, pass through our Ethernet and then are captured by the Wireshark. So we exchange information, and then the information is passed through back to our computer through Ethernet, and it's sent to the Wireshark. Now, what we want to do is we want to use the filter, and that's going to be found in here. So we're going to type HTTP in, and that's going to only cause HTTP packets to be displayed. So we can go back to our Wireshark, come in here, HTTP, click enter, and we see that this is what we should get if we did it all correctly. So we have a get, and we have this right here. Minimize this, going back to instructions. We need to find the HTTP get message that was sent from our computer to the server. So this message was sent from the computer to the server. The source is the IP address. So we have number, and we can see that the number is going to the right, and that means it's going away from home. So left is home, I guess right is where it's going away to. We have the time that it was sent, and then we also have our number 898, and then we can see that it happened at 900. We have the source, which is the IP, our IP, then we have the destination IP, and then we have our protocol length, then information about it, and then coming back to us at number 900, we have the time, we have the source from when it came from. So the source down here was the previous destination up here, and now the destination was the source. So we can see that it's going back and forth. When we select the HTTP GET message, the Ethernet frame, IP datagram, TCP segment, and HTTP message header information will be displayed in the packet header window. And we can expand this and also minimize this. And then we can exit Wireshark, and we are done. So if we come into here, we have all these different things that we can click on, and we can expand all this different information. But I don't want to expand all this different information, so I'm just going to minimize that. The part that I care about is this hypertext transfer protocol. So we can click that, and we get this information right here. And it looks like I did not do it correctly, so what I'm going to do is I'm going to continue without saving, and so it refreshes it. And what I'm going to do is I'm going to go back into the Chrome tab. What I'm going to do is I'm going to take this link, I'll copy it, close this, and then I'm going to paste it into a new Chrome tab. So go here, paste and go. So I guess I didn't get it right because I never captured it, but what I did is I went out of here, I refreshed the page, and it finally showed up here. So this is what we wanted to look at. This was something totally else different. This was also something totally different, and this was totally different. I know it was different because I did this previously, just once over, and I noticed the destination was different. But now this is the correct destination that we should be looking at, and of course for all of these, my IP address, so where it comes from, and then the destination for it should be the same. Now we see we have all these different things that are popping up because there's other things running in the background. But what we can do is we can stop it, we can continue without saving by refreshing it, and then what I'm going to do from here is I am just going to go back to our Chrome tab. I'll refresh it, and then hopefully it'll show back up in here, which it does. So to stop anything else from being captured, we can click the red, and now we just have this here. So this is correct, and what we can do is we want the information here, so we can double click, expand it, and we want this information that is inside of here. For the lab document, we need to list 3 different protocols that appear in the protocol column of the unfiltered packet listing window. So what we can do is go back to our Wireshark, we will exit out of our filter, and we're just going to select 3 of the different protocols that we see. So we have UDP, TCP, and QUIC. So that's it for this one. And then it's asking us how long did it take to get the package. Well, I've done this before, so it's at a different time, different number, and so the time request will be slightly off, but an easy way to actually get this without having to do some calculations. And again, we were going to go back to our HTTP. We could subtract these 2 times, or we can click this, and I'll bring this down, and it says time since requested. And that is going to be our time, because it's the time since it was from here. This is where we requested it, right? It's not going to say it here, but it will say it if we click the OK, because this is after. This is when we requested it. So getting it, and then we request it. And then we have what is the internet address of the server. That's going to be this address. And then we have my address, because it's asking what's the address of the computer, the specific computer. So that are both there. And then we have to print the 2 HTTP messages from the get and OK refer to, and click OK. And to do that, what we're going to do is we're going to go back into our Wireshark, and we're going to go to File, we're going to go to Print, we're going to make sure we only have the selected packets that we want, and then we're going to have Display clicked, and then we can click Print, and then I just have it being sent to my OneNote, and that way it'll go there and I can look at it. And then it's going to print out this information, so I'll click Print, and then it is open right here. And so we have all the information, and that is how we would write out the lab report as well for this lab, and how we would look at the Wireshark.